Hi, and welcome to my podcast on Le Châtelier's principle. In this podcast, I'll help you understand what this is and exactly how to use it in Chemistry 1 and AP Chemistry. This concept is actually really easy to get after a little bit of practice. So, what is this, and where did it come from? Le Châtelier's principle is named after a French chemist named Henry Louis Le Châtelier, who lived during the late 19th and early 20th centuries. It states that the system always acts to oppose changes in chemical equilibrium. To restore equilibrium, the system will favor a chemical pathway to reduce or eliminate the disturbance, so as to restabilize that thermodynamic equilibrium. In other words, it states that if a stress is imposed on the system, the position of equilibrium will shift in the direction that reduces the change. You can imagine equilibrium as a balance. If weight is added to one side, the pivot point must be moved to regain balance. So, what exactly can affect the chemical equilibrium? Only three changes can cause equilibrium to shift. These changes are concentration, temperature, and pressure. Here's how concentration can affect equilibrium. When a component is added to one side of an equilibrium, the equilibrium will shift away from the added component. This works in a similar way when the component is removed. Equilibrium will shift towards the side in which the component was removed to regain balance. In the example below, 50 grams of carbon bisulfate is added to an established equilibrium. The added component will cause the equilibrium to shift towards the reactants because the added component is a product. This means the concentration of the reactants will decrease, while the concentration of the products will increase. This makes sense, of course, because the added component is a product. If more product is added, the concentration of the products must go up for the reaction to make sense. Now, time for changes in temperature. When temperature is changed in a chemical equilibrium, equilibrium will shift depending on whether the reaction is endothermic or exothermic. Heat must be thought of as a reactant or product when dealing with Le Châtelier's principle. If the reaction is endothermic, heat is a reactant. And if the reaction is exothermic, heat must be thought of as a product. The reaction below is the reaction used in the Haber-Bosch process. This is the process companies use to make ammonium. In this example, there is a negative delta H, so this is an exothermic reaction. Since the reaction is exothermic, heat is treated as a product. Since the temperature is being raised, product is being added, so equilibrium will be shifted towards the left. Like I said earlier, you have to treat heat as a product or reactant. You can think of this problem in the opposite way. If you lower the temperature, you're taking away product, so equilibrium will have to shift towards the right. Pressure is the last thing that can affect equilibrium. An increase in volume shifts the equilibrium towards the side with more moles of gas, while a decrease in volume shifts the equilibrium towards the side with fewer moles of gas. You can remember this by thinking that more pressure equals less moles of gas, while less pressure equals more moles of gas. Another way by thinking of this is that less volume equals less moles of gas, while more volume equals more moles of gas. If both sides of the reaction have the same amount of moles, no shift in equilibrium occurs. This is the case because an equal number of moles of gas prevents the shift in equilibrium from counteracting the changing pressure. In this example, the volume of the container is decreased, so the pressure inside increases. This means the equilibrium will shift towards the side with fewer moles. The reactant side has 2 moles of gas, and the product side has 3 moles of gas, so the equilibrium will shift towards the left. Here are a few things to keep in mind when solving problems dealing with Le Châtelier's principle. First of all, the addition of an inert gas has no impact on equilibrium. An inert gas is just a gas that isn't part of the reaction. Another thing to consider is that a catalyst has no effect on equilibrium. It just makes the reaction occur faster. Here are a few practice problems for you to try on your own. Just predict a change in equilibrium. The answers will appear on screen in a bit. I hope this podcast has helped you understand this concept a little better. Thanks for watching.